All right, here we go for our review for exam number 2. The time is basically 3 days, Friday, October 30th, starting at 8 in the morning, all the way to midnight on Sunday. So you'll have most of Friday, all of Saturday, all of Sunday, in which to pick 2 hours of uninterrupted time. Keep in mind that once you start, you can't stop and take a break and start again. It's uninterrupted time. There are only 23 questions. No late testing, no makeup, so don't even waste your time asking. This is your open window for the test. No late testing, no makeups. This is 20% of your grade, so give a focus to what's going to happen during this exam. I'll put this video review on my YouTube channel. The notes, whatever the problems that I work out on the paper here, that will go on your Module 2 under Blackboard. So let's begin. It says, consider the polynomial. There it is. Express in descending order. And what that means is descending order of exponents. So 4x to the 9th, largest exponent, right? 9x to the 4th. Got some x squared, that's minus x squared, plus 6. That wasn't hard. Descending order. Once it's in descending order, it says identify the degree. What does the degree mean? The largest exponent. So there it is. Don't put 4x to the 9th. That's not the whole term. It's just the largest exponent. So 9 is my degree. Identify the leading coefficient. Find your leading term. Find the coefficient of your leading term. Just 4. All right, number 2. Add or subtract is indicated. This one is a subtraction problem. You know that when I subtract things in parentheses, I change their sign. So let's go ahead and rewrite this without the parentheses. It's minus 2, minus a negative, that's plus 5y to the 3rd. And when I write my summation, I might as well put it in standard form, the largest exponent first. I'm going to do this term first. I notice that I have like terms with the y to the 3rds. Minus 7 plus 5 is minus 2. And I notice also that I have like terms here. Plus 9 minus 2 plus 7. So that's what you put for your final answer. All right. Number 3. Consider the following function, it says. There it is, negative 6/7 x to the 3rd. Step 1, identify the general shape of the graph. Now, what you're going to want to have handy when you do this is your chart of the basic functions. It's two-sided. I've sent it to you before. I'll send it to you again. But it's the basic functions. 6, 7, 8, 9 of them. And basically, I want to look for the graph that talks about x to the 3rd. This is just a variation on that theme, negative 6/7 x to the 3rd. So what does x to the 3rd look like? There it is. So it basically looks like this. I have to keep one thing in mind, though. I have a negative number in front of that x to the 3rd. So what that's going to do is flip everything over the x-axis. So this will be down here, that'll be up there, and it'll look, oh my goodness, just like this guy right here. So that wasn't too hard. Identify the general shape of the curve. You're going to use your basic functions chart on that. Secondly, find 2 points on the graph of this function other than the origin. Now remember, if I have t to the x, I can also express that as y equals. negative 6/7 x to the third. Again, make it easy on yourself. Pick an x that's going to make it easy. Here's an easy x. Remember, I can't choose 0, so I'm going to pick 1 for my x. 1 cubed is 1. Negative 6/7 times 1 is negative 6/7. It says I can express it as an integer. I did. Or a simplified fraction. I did. So 1 negative 6/7. When you put that there, the point's going to show up. All right, let's try another easy one, negative 1. Because it's easy to cube negative 1. Negative 1 cubed means negative 1 times negative 1 times negative 1. That gives me negative 1. So this will give me negative 6/7 times negative 1, 6/7. Again, make it easy on yourself. Pick a gentle x, and remember that your function may be expressed as y equals. All right. Consider the following piecewise function. Remember what a piecewise function is. It is basically a schizophrenic function. It hasn't made up its mind what it wants to be when it grows up. So if you have an x that's less than or equal to negative 2, negative 2, negative 3, negative 4, negative 5, negative 5.5, negative 20,000, something like that, any of those x's, then this is how you define the function. If, however, you're talking about x's that are greater than a negative 2, that's how you define the function. So the first thing you're going to have to do when you're looking at a particular value is decide which part it's in, which piece of the function, which type of the function defines your particular value. First one, find the function defined at x is negative 2. So we want to find f of negative 2. All right, first thing first. Which one is it in? Is negative 2 part of this? X is less than or equal to negative 2? Is negative 2 less than or equal to? Yeah, it's equal to negative 2. It's in this first one. So it basically means 3/4 times whatever my x is plus 3. So I'm going to think of this as negative 2 over 1. Multiply these two fractions. I get negative 6/4 plus 3. I could evaluate negative 6/4 as negative 1.5 plus 3. That's positive 1.5. And use your calculator if you need to help you. All right, next one. How about x is negative 4? I want to find f of negative 4. First thing I need to do is decide which expression is to define f of negative 4. Is negative 4 less than or equal to a negative 2? Yeah. Negative 4 is less than negative 2. So I'm going to still use this first expression. And I'm going to put the negative 4 over 1 since I'm going to multiply two fractions plus 3. It's 12 over 4. It's negative times a positive. Negative 12 over 4 plus 3. But that's just negative 3 plus 3. That's 0. So my answer, 0. All right, how about this guy? X is negative 1. I want to find f of negative 1. Again, which piece of the function defines it? Negative 1. Is negative 1 greater than negative 2? It doesn't seem like it is, but it is. Think about it on the number line. Here's negative 2. Here's negative 1. Here's 0. Anything to the right of something is greater. So negative 1 is greater than negative 2. So I'm going to use this one right here. which says negative 2 times whatever my x is, which is negative 1, minus 3. Negative 2 times negative 1 is 2, minus 3, negative 1. So again, when you're asked to evaluate the function, first of all decide which piece of the function defines my particular question. Right, consider the following function. There it is, r of x equal, in parentheses, x plus 4 cubed. It says determine the basic function that has been transformed. And I don't think I have to tell you, this function is something cubed. So once again, f of x equal x cubed is the basic function that is being transformed. So identify the shape of the basic function. X cubed looks like that. So that is exactly what I'm looking for when I go here, and there it is. Not too bad, huh? Determine the basic function. Oh, I'm sorry. Determine the basic function means I need to write the function first of all, and that is r of x equals x cubed. So that is the basic function, and then there's the graph of the basic function. So you got two things to do. Come up with the basic function, that is in x's and y's, and secondly, the graph of it. Not too bad. Which means you better have this basic function chart handy when you're doing your test. Number 6, find the open intervals where the following function is increasing, decreasing, or constant. Express in interval notation. Now, when I'm looking for these intervals that are increasing, decreasing, or constant, remember, I am looking as I am moving right to, that's odd, right to left. Right to left. So as I'm moving this way, what is the graph doing? Well, as I'm moving this way from negative infinity, look at your graph, it's decreasing. So as I'm moving this way, my graph is decreasing, and it's decreasing all the way from negative infinity, all the way that way, all the way to, what is this? 1, 2, it's negative 2. So it's decreasing from, and they want me to put it in interval notation, from negative infinity all the way to negative 2. That's when it stops going down, right? Now keep in mind, this point, negative 2, is a transition point between where it's decreasing and where it's increasing, so I do not include it in the decreasing interval. So that means I put parentheses. Always use parentheses in these intervals. That's what an open interval is. All right, decreasing. How about where it's increasing? Well, it's increasing starting here, going all the way to the right. So it's increasing from negative 2 all the way to infinity. Again, negative 2 is not in either one of the intervals. It's a transition point. So that's how I'm going to talk about the increasing interval. And as far as constant intervals, that's where it's just, the graph is just going straight across. I don't have any of those. Won't necessarily have each of these in any particular graph. So again, you're moving from right to left. What is the, did I say right to left? You're moving from left to right. And as you move from left to right, you decide what is the graph doing. It's going downhill, 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 stops, goes uphill, uphill, and there is no constant interval. All right, better get my left and my right. It's always a problem. All right, consider the following functions. Here's all I need to know. F of negative 2 is negative 1. G of negative 2 is positive 2. And I want to find the 4 combinations: the sum function, the difference, the product, and the quotient functions. And all I need to do is know what this means. F plus G of negative 2 means F of negative 2 plus G of negative 2. That's all it means. And I am given what F of negative 2 is. F of negative 2 is negative 1. That's negative 1 plus G of negative 2 is 2. Why, that's 1. Next, F minus G of negative 2. What does that mean? Why, it just means F of negative 2 minus G of negative 2. Again, I know what F of negative 2 is. It's negative 1. Minus, what's G of negative 2? 2. Negative 1 minus 2, that's negative 3. F times G of negative 2. That simply means F of negative 2 times G of negative 2. That's all it means. F of negative 2 is negative 1. G of negative 2 is 2. Multiply those two together, negative 2. And finally, F over G of negative 2 simply means F of negative 2 over G of negative 2. That's negative 1. G of negative 2 is 2. Negative 1/2. Not tough at all. But I do have to know what the definitions of the sum, difference, product, and quotient functions are. All right, here's our fifth type of combination of functions. It's none of these familiar operations. It's a new operation called the composition of functions. F of G of 1. This is the composition of functions. I was able to remember what that is today. So happy. Find F of G of 1 for the following functions. Round to 2 decimal places if necessary. So I have 2 functions, and I'm asked to find F of G of 1. Okay, what does F of G of 1 do? It simply means this. The first function evaluated at the second function. So if you will simply have this in your notes visible, you can do what F of G of 1 is. It's simply F of G of 1. There's an order of what I need to do inside the parentheses first. I need to find G of 1 first. Then once I do that, find F of that. So I'm going to work from the inside out. G of 1. Here's G of x. G of x is the square root of 4 times x. So G of 1 is the square root of 4 times 1. That's the square root of 4. Why, that's 2. So F of G of 1 means F of G defined at 1, which is the square root of 4. That's 2. So now what I have to do is evaluate F, the function F, at 2. So let's go up here to F. F of 2 means 5 plus the square root of 2. Whatever your x is, the function F says take the square root of that, add 5. So I take the square root of 2, add 5. Obviously, rounding to 2 decimal places, I'm going to need my calculator here. Unless you happen to know what the square root of 2 is. Let's find out. Square root, where's my square root? Oops, this is the one I use. This is the one that has a visible square root. So I'm going to take my square root. The other one's a second function, kind of invisible. So I get 1.4142 etc. And that gives me 6.4142, etc. And I want to round to 2 decimal places, which means I go to the third decimal place. If it's 5 or bigger, I round that up. If it's 4 or less, which it is, I leave this alone. So I'll leave it alone. So the answer I submit, rounded to 2 decimal places, is 6.41. All right, number 8. Number 9, consider the relation. And remember, one way we can talk about a function or a relation is as a set of ordered pairs. And here's just a set of ordered pairs. These are my x's, these are my y's. It says find the inverse. Remember what the inverse of a set of ordered pairs is. It's just the reverse of each of those ordered pairs. So that's how we indicate the S inverse. The inverse of S is, and it's a set. It's got a bunch of ordered pairs, and each ordered pair is simply reversed. -10, 1, no, 1, -10. -1, 3, how about -3, -1? 5, 1, -2, 7. So I have just reversed each of the ordered pairs to get the inverse of my relation. Second part, find the domain and range of the inverse of this guy, not that guy, this guy. Remember what the domain is. It is the set of all first elements. It's what shows up in your ordered pairs first. And the range is your set of all second elements. So my domain, it says, expressed as a set of numbers. So my domain is, here's my set notation. The numbers are, the first elements, 1, -3, 5, -2. And likewise my range, the set of all second elements, expressed again as a set of numbers, -10, -1, 1, and 7. And that's as straightforward as that is. All right, your next section is factor. Factor the trinomial if possible. Keep in mind that as we factor a trinomial, certain things are obvious, because when I multiply these two binomials, I will be FOILing them, foiling them. This guy comes about, this first term comes about as a result of these two terms multiplied. The only things I can multiply to get 2x squared are x and 2x. I mean, that is literally it. One thing you'll also know is this last sign being positive says my two signs are the same, and that sign tells me what they both are. This says my two signs are both positive. Look there, I'm 2/3 of the way through and I haven't even broken a sweat yet. Hey, and the only thing that can multiply to give 5 is either 1 and 5, 5 and 1, -1, -5. It can't be negative. So 1 and 5 or 5 and 1. That's it. Now I got to get 11x from my outer and inner multiplications. From the O and the I, they have to add to 11x. And the only way that's going to happen is if the 5 goes here and the 1 goes there. Let's check it. X times 2x is 2x squared. x times 1 is x. 5 times 2x is 10x. 5 times 1 is 5. Looky there. 2x squared plus 11x plus 5. It checks out. And by the way, if you put 1 and 5 here and you checked it and you didn't get the same thing, just reverse the two terms, 1 and 5. Not too difficult. All right, factor the trinomial if possible. Here we go. Now note this guy has a 1 in front of the squared term. This one didn't, so I had to be a little bit more careful. This one has a 1, understood 1, in front of the squared term, so I can ask myself the two-part question. What two numbers multiply to give 12, this term right here, and add to get this term right here, 12? All right, so I'm looking for two numbers that multiply to give 12 and add to give 12 also. Start always with your multiplication options. Those are very limited. The addition options are infinite. So I start with my multiplication options. What can I multiply to get 12? Well, 1 and 12, negative 1, negative 12, 2 and 6, negative 2, negative 6, 3 and 4, negative 3, negative 4. That's it. That's all I can multiply to get a positive 12. Now here's the question. Which of these pairs of numbers also adds to give a positive 12? None of them. None of them do. That adds to give 13, negative 13, 8, negative 8, and so forth. None of them add to give 12. So factor the trinomial if possible. Choose the not possible option. Everything doesn't necessarily factor. All right, factor if possible. Please note, 1, 2, 3, 4. 4 terms. Do you remember what 4 terms indicates as far as factoring? 4 terms says you're going to factor by grouping. That is your big hint. And I literally group my terms into pairs. So pair up terms based on what they have in common. Hey, these two guys both have a B, right? So I'm going to put these two guys together. And check this out. These two guys both have a Z. So both pairs have something in common. All right. Step 2, factor out common factor. We saw something the two terms had in common. These two guys both have a B. Factor it out. What does that leave? R plus T. What do these two guys have in common? A Z. Factor it out. What does it leave? R plus T. Now, these guys have to be identical. They have to be identical because my next step is to factor out the common binomial factor. If they're not the same, if they're opposites of each other, go back and start over, check your sign, do something to make sure they end up being identical. Factor out common binomial. That's the common binomial. Let's factor it out. Make sure it's in parentheses. When I factor out R plus T, what's left? Why, B plus Z. There it is. And put the B plus Z in parentheses too. So you will get a binomial times a binomial when you factor by grouping. And make sure you put the parentheses there. If you don't put the parentheses, you're not multiplying a binomial times a binomial. All right, once again, 4 terms, factor by grouping. Factor if possible. Why, that's easy. This is the difference of two squares. And the difference of two squares will always factor, and it will always factor into something plus and something minus. The square root of this guy, here and here, that's just x. Square root of this guy, here and here, always a plus and a minus. That's pretty easy. All right, factor if possible. Here's when I go, hey, you know what? The first thing I always check for is a common factor. And look, I do have a common factor, don't I? These are all even numbers, so I'm going to factor out a 2 before I go any further. That'll make things easier. X squared 11x plus 30. And then I'm going to check what I have in parentheses, this trinomial. Notice 1 in front of my squared term. That means I can ask the two-part question, what two numbers multiply to give that, add to give that? What two numbers multiply to give 30, add to give 11? Well, hopefully you don't have to think too hard. 1 and 30, 2 and 15, 3 and 10, 4, 5 and 6. That's about it, huh? And plus and minus those, you can have them both negative. That's all you can multiply to get 30. Which one adds to 11? Right there. So my trinomial factors into x plus 6, x plus 5. But ladies and gentlemen, do not forget that 2. That 2 is part of your final factorization. This trinomial factors into these two guys. The 2 is an additional factor. It's part of it. So there's your factored polynomial, trinomial. All right, solve the polynomial equation by factoring or by using the quadratic formula if it doesn't factor. Some things don't factor, right? So here we go. Hey, 1 in front of the x squared. So I can ask myself the question, what two numbers multiply to get 34, add to get negative 6? Okay, multiply to give 34. What'll go into 34? It's even. 2 times 17. Negative 2 times negative 17. Neither of those is going to add to negative 6, is it? So you know what? This guy doesn't factor. By factoring or factoring, it doesn't factor, so I'm going to have to use the quadratic formula, which means I'm going to have to indicate what A, B, and C are for my quadratic formula. Remember the A? It's whatever's in front of x squared. B, whatever's in front of x. And C is your constant number. So my A is 1. My B is negative 6. And my C is 34. All right, you're going to have this handy. If you have your notes, you'll have it handy. Here it is. If you're using the quadratic formula, x is the opposite of b, the negative b, plus or minus. That's how you're going to get your two answers. The square root of b squared minus 4ac. Everything over 2a. Now all I need to do is fill in my a, b, and c. So here we go. The opposite of b is negative 6, so the opposite of b is 6, plus or minus, big old square root. B squared, that's negative 6 squared. This will always be a positive number, ladies and gentlemen. B squared will always be a positive number. Minus 4 times a times c. All over 2 times a. So I get 6 plus or minus square root of Negative 6 squared, always positive, is 36 minus 4 times 34, 4 times 6 squared, 136. Uh-oh, that's going to be negative. All over 2. I get 6 plus or minus the square root of 36 minus 136 is negative 100 over 2. Here's where we're going to need to just pause for a second. Check this out. I've got the square root of a negative. Put that in my calculator, it's going to say error. Why? Because this is in the realm of complex numbers. You get a square root of a negative, you have yourself an I expression. So this is 6 plus or minus I times the square root of 100. The negative 1 becomes, square root of a negative 1 becomes the I. And by the way, you can do this more steps in one than I'm doing. I'm taking it slow here. Square root of 100 is 10. Look at that. Everything's divisible by 2. So divide 2 into that, 2 into that. And there's my solution. Now, I believe it's going to ask you to write 2 solutions. So I'm going to write 3 plus 5i as one solution and one blank. And I'm going to write 3 minus 5i in the other blank. I don't think it's going to give you a plus or minus option. All right, quadratic formula. All right, 16. Identify the correct graph and the x and y intercepts of the following polynomial function. Express all points as ordered pairs. All right. S of x is x minus 4, x plus 5, times 1 minus x. All right, first of all, x and y intercepts. Let's find the x intercepts. X intercepts. T-E-R. How do you find an x-intercept? You let y equal to 0 and solve for x. I don't see a y. Oh yeah, that's the same as y. So everywhere there's a y, I'm going to put 0. Okay, now what do? I set each of these factors equal to 0 and solve. That's not hard. Add 4, x is 4. Subtract 5, x is negative 5. Move the x to the other side, x is 1. These are my x-intercepts. So whatever this graph does, it's going to cut the x-axis at the points, negative 5, 1, and 4. So it's going to be some kind of graph. It's going to go up and down because it's got to come back to those points. So it's going to cut the x-axis at negative 5, positive 4, and positive 1. Now, as I look at my graphs here, negative 5, nope, this isn't it. So this graph doesn't cut at negative 5. This is hard to figure out here. Negative 5. Oh, this is coming down here, so -5, +1, and 4. This could be it. -5, +1, +4. That could be it. -5, 1, and 4. So these guys are possible options. We've eliminated this guy, but these guys are all possible options because they all have x-intercepts at 4, -5, and 1. All right, let's find the y-intercept. Maybe that will clear things up. How do I find a y-intercept? Why, I let x equal 0 and solve for y. So in this expression right here, I'm going to let x equal 0. That means everywhere there's an x, I'm going to put a 0. So I get 0 minus 4, 0 plus 5, and 1 minus 0. What do I get? -4, 5, 1. I get -20. So this graph, whatever it looks like, cuts the y-axis way down here at the point -20. So let's see if one of these guys looks like it cuts the y-axis at the point -20. Hey, look at this guy. Now this is 30, so that must be 20. Look at there. -20. Right there. -20. Nope. So this is my graph. The graph that has the x-intercepts of 4, 1, and -5, and the y-intercept of -20. That's it. So my x-intercepts, let's see, express all points as ordered pairs. So my x-intercepts are 4, 0, -5, 0, ordered pairs, and 1, 0. I don't just say my x-intercepts are 4, -5, and 1 because why not? Because they told me how to do it. My y-intercept is at the point 0, -20. All right. So this is important. How do you find an x-intercept? You let y equal 0 and solve for x. How do you find a y-intercept? Let x equal 0 and solve for y. All right, consider the following polynomial. I'm considering it. First of all, it says find the degree. That's the largest exponent, right? That's just a 2. And the leading coefficient. Find my leading term. It's this whole thing here. The leading coefficient is right there. That's a 6. Now, this says describe the behavior of the graph as x approaches both positive and negative infinity. What that means is as x gets very large, that's approaching infinity, or as x gets very small. That's what we mean by approaching negative infinity. It gets very small. So it would be nice to know what this graph looks like. Some of you already know. This is a variation on one of our basic functions. In fact, this is a variation on s of x equals x squared. This guy right here is a parabola. Question, is it an upward or a downward turning parabola? How do we know? If this number in front of the x squared is positive, I have myself an upward turning parabola. Now, this picture that I'm going to draw is not intended to be representative of this, but simply to be representative of that. I got me an upward turning parabola. Why? Because my x squared term has a positive coefficient. That's all I need to know. So check this out. As my x's, these are my x's right here, as my x's are approaching infinity, what's happening to my graph? Is it getting larger or smaller? It's getting larger and larger and larger and larger. As x approaches infinity, my y values, my s of x, are approaching infinity. They're getting very, very large. Check this guy out. As my x's are getting very, very small, my y's are getting very, very large again. They're not approaching negative infinity. As my x's get very small, my y's are getting very, very large again. So my s of x is approaching infinity as well. So if I can sketch the graph, and depending on what this is, positive or negative, either my y's are going to be getting very large, or if it was like this, they'd be getting very small. But what this means is as x approaches infinity, which means as x gets very, very large, or as x gets very, very small. All right, so get a general picture of the thing, and you can answer the question fairly easily. All right. Solve the following polynomial inequality expressed in interval notation. All right, got some steps here. Let's do our steps. First step, I need to set the thing to 0. I need to have 0 on the right side. So I need to get everything over here on the left. And remember, as I move a term, it changes signs. All right, I have set the thing to 0. Is that good? Step 2. Factor, and you don't have to worry about this not factoring on this problem, this type of problem. It will factor. Factor the polynomial. In this case, is a trinomial. Hey, it's got a 1 in front of my squared term, so I'm looking for two numbers that multiply to give -6 and add to give whatever's in front of my x here. What's that? 1. So I'm looking for things that multiply to give -6. Let's see, -1 and 6, 1 and -6, 3 and -2, -3 and 2. Any of these add to +1? Yeah, that one right there. So it's a +3, a -1. So +3 minus, that's a 2, -2. And I have factored the trinomial. Number 3. Set each factor equal to 0 and solve. That's not going to be hard. Subtract 3 from both sides, x is -3. Add 2 to both sides, x is 2. Here's where the inequality part, if this was an equation, that would be my solution right there. I'd be finished. But an inequality says my solution set is going to be part of the number line. These two values are my critical values. They mark the number line. So -3 and +2. Now, notice I did not put a 0 in there. Why? Because it's not one of my critical values. Only put your critical values on the number line. Notice what's happened. These two values have divided the number line into 1, 2, 3 sections. And here's the truth about these sections. Either everything in this section works or nothing does. Everything in this section works or nothing does. Everything or nothing. So how am I going to find out which sections work and which don't? I'm going to test values. Test something in each of the sections. If that test works, then the section works. If that test fails, the section fails. So let's try 3. 3 is in this section right here, right? So let's test this section by testing 3. What that means is I put 3 into this inequality and see if it's true or not. So here we go. 3 squared plus 3 minus 6. Question is that less than or equal to 0? 9 plus 3 minus 6. Is that going to be less than or equal to 0? No. 12 minus 6 is 6. Is that less than or equal to 0? No. 6 is not less than or equal to 0. So this section, this value, and thus this section fails. This is not part of my solution set. Let's test something in here. If 0 is an option, always use it. It makes it very easy. Let's test 0. It's in here somewhere, right? That means 0 squared plus 0 minus 6. Is that going to be less than or equal to 0? It's negative 6 is less than or equal to 0. Is that true? Absolutely. Negative 6 is less than or equal to 0. This value works. That means this whole section works. This is part of my solution set right here. Let's see if this guy works. Let's test, let's say negative 4. So I got negative 4 in parentheses squared plus a negative 4 minus 6. Question, is that going to be less than or equal to 0? It's positive 16 plus a negative 4 is minus 4 minus 6. Is that going to be less than or equal to 0? That's 12 minus, that's 6. Is 6 less than or equal to 0? No. That's a false statement. This guy does not work. So my solution set is right here, from negative 3 to positive 2. Now watch carefully, because this is going to be the difference between a correct and an incorrect answer. Am I going to use parentheses or brackets for my interval notation? My inequality symbol will tell me. This has an equal to sign. That tells me I'm going to be using parentheses. Got that? If there's no equal to sign in there, if it was just less than, parentheses. Since it has an equal to sign, brackets. I'm going to be using brackets since it has an equal to sign. So whatever my interval notation solution is, it's going to have brackets. So from negative 3 to positive 2, negative 3 to positive 2. I bracketed it. Why? Because I have an equal to sign in my inequality. So there is your solution in interval notation. Once again, you're not going to get a chance to correct this. So if there's no equal to sign, that's parentheses. If you have a equal to sign, that's brackets. All right. Number 19. Find the restricted values of x for the following rational expression. And we're talking about restricted values. You're talking about values that make the denominator 0. So what do? Number 1, I set my denominator, just the denominator, equal to 0 and solve. Here's my denominator. Set it equal to 0 and solve. Hey, that's a polynomial. I need to factor the guy, right? First thing I always look for in factoring a polynomial is a common factor. What do these two guys have in common? If you said 9, you're partially correct. If you said x, you're partially correct. What do they have in common? 9x. Take out as much as you can. 9x times what gives me 9x squared? X plus 9x times what gives me 9x? 1. So I have factored, set the denominator equal to 0 and solve. I have factored my denominator. The way I solve it is set each factor equal to 0 and solve. Subtract 1, x is -1. Divide by 9, both sides, x is 0. So find the restricted values. Restricted values are 0 and -1. That's it. That's all you got to do. Set the denominator equal to 0 and solve. Those are your restricted values. All right, you will have, it might not be number 20, it might not show up as number 20, but you will have one asymptote question. Don't worry about it. We did not cover that. It will not count against you. Even though it looks like it has counted against you, it won't. Hey, if you want to go ahead and do it, go ahead. It could be a bonus. It's not gonna hurt you. It can only help you. All right, last 3 questions deal with exponents. It says use the properties of exponents. Here's the first property of exponents that says if I'm multiplying factors that have the same base, I add my exponents. Keep the base, add the exponents. Most of you guys would do this in your head. I'm going to show it on paper. Hey, make sure that positive exponents only are in your final answer. That's a positive exponent. So I'm finished. All right, same thing here, same instructions. Positive exponents only in your final answer. Hey, that's not a positive exponent. So I got to deal with this guy. Here's my concept that I'm going to use to deal with it. And that is this concept. I am free to move a factor to the other part of the fraction if I change the sign of my exponent. So I can move this factor, since it has a negative exponent, to the denominator and make my exponent positive. It's that simple. Hey, if I had something like this, A3B -5. Hey, I don't have a fraction. Yeah, you do. You always have a fraction. So whatever is the problem, the negative exponent, move to the opposite part of the fraction and change the sign of the exponent. What if it's something like this? Yeah, how about that? Hey, there's a problem. That's the part that is not simplified because I only have positive exponents in my final answer, so this cannot be a final answer. But I do the same thing. Move the factor to the other part of the fraction and change the sign of your exponent. So this would be y to the 6th over x to the 4th. Pretty easy, huh? Final. Simplify using exponents, only positive exponents only in my final answer. Here's the one concept I'm going to rely on. Anything to the 0 power is what? It's 1. So this parentheses raised to the 0 power is simply going to be 1. Do that first, and it kind of simplifies enormously after that. -2 times 1, -2. Finished. So find what's to the 0 power and deal with that first. Notice it's not the whole thing to the 0 power. It's just what's in parentheses to the 0 power. All right, good luck to you. I will post this video and I will post these notes on Module 2 under Blackboard. Good luck. Don't wait till the last minute. That's where last-minute problems happen universally. So you have most of the day Friday, all day Saturday, all day Sunday to get this done. Good luck.